This session is on developing a program to determine a factorial of a given number. So let's understand the problem. So what is a factorial? So if you see 0 factorial is 1 and 1 factorial is 1, 2 factorial is nothing but 2 into 1. 3 factorial is nothing but 3 into 2 into 1, which is 6. 4 factorial is nothing but 4 into 3 into 2 into 1, and goes on. Like 5 factorial is 120, which is 5 into 4 into 3 into 2 into 1. So you start from 5 and go till you reach 1, and you multiply all those values. Okay, so if you see through this, 1 factorial is nothing but 1 into 0 factorial. 2 factorial is nothing but 2 into 1 factorial. 3 factorial is nothing but 3 into 2 factorial, where 2 factorial is 2, and then 3 into 2 is going to be 6. Let's assume 4 factorial is nothing but if 4 into 3 factorial, where 3 factorial is equal to 6, 4 into 6 is equal to 24. Same is the 5 factorial, 5 into 4 factorial, which is nothing but 5 into 24. Okay, so if you know the factorial of the previous number, you will be able to determine the factorial by multiplying the current number with the previous number's factorial. So it is nothing but n factorial is equal to n into n minus 1 factorial. Okay, how do we calculate this manually? Like it's very pretty easy. Like if I give a simple number like till 5 or 4, it is easy. But if I ask you to calculate 10 factorial, it is going to be a little bit difficult. So you will need a paper and pen to do that actually. So I wanted to document that steps, whatever you're doing with the paper and pen here actually. So let's take, we are considering 5 factorial. Okay, so how are you going to do this? Or how will you do it in a memory? Like in a paper, or in your memory, how we are doing it. So initially you will have in your memory as 5. So because you're going to do 5 factorial, so all that you are going to do is 5 into 4 into 3 into 2 into 1. I'm just splitting this process and trying to document that steps, which will be helping us to develop an algorithm and do the program. So you have in your memory 5, and what you do with that, you multiply that with 4 and you get 20. Now you will replace your memory value from 5 to 20. So what you have is in your memory is 20. Now what you do there, 20 is multiplied by 3 and then you get 60. And now you replace your 20 value with 60 in your memory. Now what you do next, you take 60 multiply by 2, which is going to be 120, and you are going to replace your memory with 120. Now 120 is multiplied by 1, which is going to be coming as 120. So that is your final answer, what you're going to give us. So this is your manual steps. Okay, so let's try to put this in a Java program. So we have integer factorial to represent the total value of factorial of a number. So assume that I'm going to calculate the factorial value of 5. That means I need to first have 5 in my memory. So consider this as my memory variable. Fact is equal to 5. Now first step, what I will do, I will multiply fact is equal to 5 into 4. That is what I'm doing. Instead of 5, you can make it as a fact here. So fact is equal to fact into 4. Since the value of fact is 5, it is going to be 20 now. Now fact value became 20. What you're going to do next, you're going to replace fact is equal to fact into 3, which is going to be 20. Fact is equal to 20 into 3, which is fact now becomes 60. Now you are going to make again fact is equal to fact into 2. Now 60 into 2 will be 120. So fact value will be 120, and then you are going to multiply it by 1. Now fact value will be again 120. So if you see these steps actually, I'm doing the same operation. I'm not doing anything different here. I'm multiplying fact is equal to fact into some number. And that number, if you see, it is ranging from 4 to 1. So 4 is nothing but the previous number of the value I'm using actually. Fact is equal to 5. So it is nothing but 5 minus 1 is the one which I'm starting with. So instead of having 4, 3, 2, 1, I can put a loop there actually. So instead of doing this operation 4 times, I can simply replace the 4, 3, 2, 1 with a value called I, and I can just put a for loop above it which says I is equal to fact minus 1, that means 5 minus 1 4, and then it has to go till it becomes 1. So I'm saying I greater than equal to 1 is the condition. So 4 is greater than equal to 1. Then it goes inside the loop and it performs 5 into 4 and fact becomes 20 now. Now I have to get decremented, so I put I minus minus. So 4 is going to become 3. 3 is still greater than or equal to 1. So it is going to go inside the loop and it is going to make 3 into whatever the value calculated before, which is 20. 20 into 3, which is going to be 60. Now again it is going to perform like it is going to, now I is becoming from 3 to 2, and 60 into 2 will be 120. 120 into 1 will be 120. Finally, after you calculate 1, the I will become now actually 0. So since it is 0, the condition is failing and it's going to come out of the loop and it is going to print 120 here. So whatever we documented as a manual step, we are just putting it here and in the form of a program. Now the same problem we can do it using the recursion. Remember in the first slide we are talking about 2 factorial is nothing but 2 into 1 factorial. 3 factorial is nothing but 3 into 2 factorial. That is the one we are going to do it now. So in order to recursion is is a process in which a method calls itself. So if you have a function and that function is calling it itself, that is called as recursion. So you should be very careful in using recursion, and it is always better to avoid recursion if at all it is possible to do without recursion. So in our case the factorial program can be done without recursion, so it is possibly we can avoid using the recursion in this scenario. But there are few real-time problems you cannot solve without recursion. So a lot of games like Towers of Hanoi problem or chess game, all these things are done using recursion heavily. So without recursion it is hard to do those type of implement those type of solutions for the problem. So you have to learn what is recursion, and we will be using this example to learn the recursion, how it is working behind the scenes. Okay, so I want to calculate factorial of 5, and that is nothing but if I want to calculate the factorial of 5, I need to calculate factorial of 4 first actually, so that I can multiply that with 5. So in order to calculate factorial of 4, I need to calculate factorial of 3. In order to calculate factorial of 3, I need to calculate factorial of 2. In order to calculate factorial of 2, I need factorial of 1 actually. And in order to calculate factorial of 1, it is nothing but factorial of 1 is nothing but 1. I know it actually. I don't need to, or I can say factorial of 0 and make it as factorial of 0 is nothing but is equal to 1 actually. So once I calculate the 1, the factorial of 1 is going to get return the value of 1 to the calling method, which is nothing but the factorial of 2. And now factorial of 2 is calculated, which is 2 into 1 is equal to 2 here. And factorial of 2 is computed and it is returned to the factorial of the calling method, which is factorial of 3. And once the factorial of 3 method receives the value, it is going to calculate its value, which is 6, and it is going to return its value to factorial of 4. Now factorial of 4 will get 4 into 6, the factorial of 3 value, which is 6, and then it is going to multiply it and becomes a 24. That 24 is returned to factorial of 5. So finally factorial of 5 is going to get the factorial of 4, and then it is going to provide the result to the calling method. So this is basically the program what we are trying to do. As you see, the program is kind of very simple, like n into factorial of n minus 1. So here is the program, or here is the method to compute this. So we are just going to write, we take a integer as an argument, and this is going to return the integer in response. So here if you see, the program is what we are doing here is, if the factorial value you receive, if I want to calculate n, if n is greater than 1, then I am going to calculate n into n minus 1. I mean n into factorial of n minus 1. Here in this factorial method, we are calling the same method again, that is called as recursion. So but with a different value. The original value I wanted to pass here is 5, but this method is calling 5 into factorial of 4. And now factorial of 4 will be taken into separate stack and it is going to execute. So that method will take 4 as an argument, and now it is in turn calling factorial of 3. It is calling itself basically with a different value. It goes on calling like this, and it needs an endpoint, right? That endpoint is nothing but when n becomes 1. If the n does not becomes 1, then you are going to get a stack overflow error, because it is going to keep on calling and it is going to create stacks for executing this functions, and finally it ends up in the overflow issue, because you will never end this program. So there should be a there should be a point where this program gets end. So here in this case, if n is greater than 1, it is going to keep on using the recursion. But if the n is not greater than 1, which is equal, when n is equal to 1 or less than 1, that time it is going to return a particular value. It is not going to go for the recursion. So that time it is going to return 1. The moment it returns 1, the previous function gets the value, gets the result, and it will be able to compute its factorial and return to its calling method. Like that, the propagation will happen till to the topmost level, and finally you get the result. So how will you call this method? You just need to say int n is equal to 5, give me the factorial of 5, and once it gets the factorial of 5, it calls factorial of 4, factorial of 3, 2, 1, and finally returns the correct factorial to the calling method. So let's try to do this in Eclipse and see how this works. So I'm going to use the utility class itself for developing this factorial program also, because it's again a utility function. So I will make it with and without recursion. So it's not going to return a boolean here, it is going to return an integer here. So I'm just making it integer, factorial of integer n. So here my method is going to say if n is greater than 1, then you have to return n into factorial of n minus 1. If not, I'm just going to return 1. That means if n is equal to 1, I'm going to return just 1. If n is greater than 1, I'm going to call the same method again and again till n becomes 1. So this is with recursion. So let's do something without recursion. So without recursion, I'm going to have to change the method name so that I will know like which method I'm calling. So I'll make the method name as factorial. Let's keep it simple, factorial 1 I'm going to give it. So here I'm going to do our regular logic, and I'm going to make factorial equal to n. So I'm going to initially assign the factorial value as the n value, which is fact is equal to 5. Remember our memory example, fact is equal to 5. And if the next step will be using a for loop and say like I is equal to start with n minus 1. So you have to multiply starting from 5 into 4, you are going to do 4, then into 3 into 2 into 1. So I is going to start from 4 till it becomes 1. So till I is greater than equal to 1, you are going to do this, and you are going to perform I minus minus. So make it as integer I so that it knows what is it. Then here you are going to do fact is equal to fact into I. So initially it will be 5. It will be 5 into 4 will be calculated. Then 20 into 3 will be calculated. And then 60 into 2 will be calculated. 120 into 1 will be calculated. And finally, once you calculate the factorial value, I'm going to return the factorial value to the calling method. So we have developed two functions here. Now we need to call these two functions from some other program actually. Basically, any program who wants to calculate factorial can simply call this two method actually. So let's write a new class for that. So we can say factorial test. So we are testing whether the factorial is working fine or not. So I'm going to have a main method here, and this main method is going to call the factorial. So I'm going to put system.out.println here and call factorial of 5. So remember, the factorial is not present. This method is not written in this class. So it is written in a different class called util. So all that you need to do is util dot. So here we say util.factorial of 5. That means it's going to call the factorial method that is present in the util class. Okay, so this is going to use recursion, but if you want to call the method that is not using the recursion, you can use that as well. So let's see the results of both this methods. So I have to use factorial 1 of 5. That's a method name without recursion. So I'm going to save this. I'm going to run this program. So both is going to give you 20, either with recursion or without recursion.